Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes. Let's create something nice today. It will be this department center here in Birmingham. It looks very special because the entire facade is made up from these circular buttons or circular panels. We also have a close-up view here. Now, using Revit curtain panel pattern based, we'll see quickly how we can recreate this whole thing in Revit. Something like this. If I zoom into here, you can see the buttons are the same as in the image. And of course, everything is fully in 3D and parametric as well. If I go to this exo view, you can see that's the whole system. By the way, if you are new to this channel, make sure to subscribe now so you can get tutorials like this coming every single day. Alright, let's get started. I will now go and make a new family. And let's go from this template, curtain panel pattern based. The first step now is to change the grid pattern from rectangle to hexagonal, this one here. And because the panel's dimensions are now a bit big, I can now change this to something more in line with the facade. How about 300 here and 420 here? Looking good. I can now hide this grid just by elements for now, just so we can focus entirely on creating the panel's geometry. We can now turn to the top view and start connecting point number 6 to point number 3 there, the opposite. Just get them both like this and then go up here, use the spline through points tool. This line, we can also turn this now to a reference line. Next step, I can now create a new point on the surface and get that point to be there, right at the middle of this new line. We can now host a new point on top of this one. For that, let's create a second point, this time on the reference plane. We can now set the plane to be the horizontal plane at that point there, this one. Once I have it set, I can now place a new point right on top and dismiss this warning about identical points in the same place. I can now escape and then select a new point and then just move it down like this. The reason why we need this second point is, if you look at the reference image, the underlying surface, which is in blue there, is curved. If our panel's center point is right on top of this surface, when the curve gets extreme, our panel's edges may come clashing into the surface underneath, and that's not very nice. That's why we need to have this second point here to offset the panel up away from the underlying surface. Now, what that offset value should be, we can control now from this parameter. We can now turn this into base offset. 76 is good for now, but how about we can go for 50 to begin with. Next step, I need to create the circle, which is the base of our button. We can now go to model line, circle line, and draw a new one on this work plane. I can now set the work plane to be the horizontal plane right there at this point location. And now press tab until I have my points highlighted. This is when I can draw the circle. This radius dimension, let's make it permanent. It's a bit big, so I can now change the scale to make it more readable. Here we go. This line as well should be a reference line. I can now be free to get this dimension there and change this radius into a parameter. Simply R for now. If I go to the top view again, you can see that the circle has to be a bit bigger because in the reference image, those buttons, they are quite close to one another. To control this radius, I shouldn't put in here a static value. Instead, this radius should scale itself up or down depending on how big or small the hexagonal panel is. Let's go now to family types. And we can tie this radius parameter to something that shows the size of the hexagonal panel. The trick is this, we need to first obtain the distance between point 6 and point 3. Let's create a dimension and set the work plane to be this plane here along this reference line. I can then select this point and then this point. This will be the overall width of my panel. I can now get this and turn that into a reporting instance parameter like this. These reporting parameters, they don't control our geometry. They simply report back whatever distances or conditions our objects are in the model. So I can now call this panel width. Next step, I need to go to family types again, and now copy this name and paste it to the R parameter. If I press enter now, you see an error, because we cannot drive a type parameter, which is radius, using an instance parameter, which is panel width. To do that, I need to go back here, select the R parameter, edit it, and then turn it into an instance parameter as well. Press OK now, and now it's working. Anyway, the circle is a bit big now, so let's put in a ratio. How about panel width divided by 2? Still bigger than the panel itself. How about 2.8? That's a bit too small. 2.5 it is then. If I now check the top view again, that looks nice. Let's now save the panel before we forget. Button panel, that's a good name. Alright, so now we have the circular footprint of the panel defined. Let's now create the geometry on top of that footprint. To define the thickness of that panel geometry, I need to drop in here a second point. Let's go to point, place on a work plane again, and this time set the work plane to be this one. Place it right on top, and I can then move it further down. This offset parameter now can be the thickness of my panel. Panel thickness is going to be. And this one can be a type parameter because it won't be in any formula. Press OK. And how about setting that to maybe 150. Next thing to do is to create the axis of our panel. Let's go to here again, make another point, this time on the face, and drop it right there. You will see a diamond snap icon lighting up, and that means we're snapping to the quadrant of the circle. So get this first quadrant, and then to the other side, get the other quadrant point here as well. I can now connect those 2 points using a spline, which should be also reference line. Next logical thing to do is to connect those 2 points below there, using the same method. Now, if you are familiar with making Revolve Forms in Revit, this is similar. This will be the axis of our Revolve, and now we need to draw a profile for the Revolve to use. To make that happen, I need to connect this point, and this other point there. That will create a reference arcs. I can now go ahead and place 2 more points. On face, at this location, and this location. Let's now connect them using another reference line. And then from this point, I can also connect it to here. And then finally, I need another point here, so I can connect this point and this endpoint using an arc. That will be another point right here. We can now try and make sure the parameter is going to be in is at 0.75. It's right there already for me, but if it's not for you, then just type in here 0.75. That will make sure that this new point will always be at the middle of this point there and this end point here. We can now get 3 points below here and connect them using an arc as well. Okay, now I can select the 3 lines that I just created along with the axis and do create form. So that's our button. It's reversed at the moment, but you will see in the project it should come to the right orientation soon. Now, if I enable wireframe, you can see that comparing to the reference image, this one looks a bit wrong because it has this funny hole in the middle. You may here start asking me why I need to have this and this additional point. The reason is I tried to do these 2 points where these 2 are, right at the center of the circle. But that gave me an error. Revit just couldn't resolve what kind of form we should make from that condition. That's why the trick is this. Place these points away from the center line. And now we slowly move them back. If I now get this one here, I cannot change the number for curve parameter. to 0.5. When I do that, if you now check the form again, you will see that the bottom of the button is now nice and closed. The top is still open. I can now select this point now and also change this to 0.5. And now everything is nicely closed. That's a trick. If Revit doesn't let you create form from a certain condition, the trick is to change that condition slightly. Make the form first, and then change the form to suit your requirements. Alright, let's now check out the front view. This button, I'm not sure if it's a bit too thick. Maybe let's change the depth to something smaller. How about 100? Yeah, that's more like it. I can now select this whole thing there and change this material to use a new parameter. Call this simply panel. We can now save this family now and start creating the form to place it on. I can now go to new conceptual mass. Get this template there and open it. In here, we need to create roughly the same form as in this photo. Now, to avoid creating a very long video tutorial, I won't try to do it exactly to the footprint of the real project. And also, we will only create one opening there instead of 4 or 5 as you see here. But the idea will be the same. We create a form, you can apply it later on when you do this again to create a full building yourself. Alright, let's create the form now. I can start with a very wavy lines like this. Just roughly the same footprint, and then modify it a bit more. Okay, I can now drop on this line or curve another reference point. This time do it on face, and you can place it anywhere. I prefer it to be somewhere there. Next step, we need to create a profile for our sweep. That sweep will then create a form for our facade. Let's now do a new reference line on the reference plane this time, and set the plane now to be this one here. It's a normal plane at this point location along this curve. I can now start drawing something like this. Here we go. I'm sure the architects put a lot more thought into this process than we do now, but anyway I can still select them too and make them reference curves. And right away, once I have still them selected, do create form now. And it's that simple. Moving on, we need to create an opening on this surface. If we look back in here, that's where the sky bridge connects into the building. Let's now draw a new reference plane for this purpose. I'll go to level 1 now, and just draw a new plane going this way at an angle of 45 degrees. Just because I want it to look straight into the corner of this building here. We can now name this one Sky Bridge. Going back to 3D now, I can now set the work plane to be that one. It's now right there. I can pick it now and start drawing an ellipse on it. We can go to model line and then choose this ellipse tool. It's a bit hard to draw because now we don't really have a way to look straight into that plane, except that we do. Let's go to the viewer tab there and click on this viewer button. What this one does is it opens up another additional view, and if I do zoom to fit now, this view is actually looking straight into the work plane that I just selected. It's a bit like using those top, front, back views here on a view cube. But with this one, you can look at any custom reference plane. That's very handy. Now because I'm here, I can start drawing my ellipse on this surface now. It should be somewhere right here in the middle where the facade curves inward. So somewhere over here. Here we go. Of course, you can do more if you like. According to the reference image, you can do one more up here, one more down here, last one there, and so on. But for today, let's do with one only. I can now close this, and now when I see this in 3D, that's looking very nice. Let's create a form from this, and make sure the new form intersects with the existing surface. I can now turn this form now into a void. And as a result, it will start cutting straight through my surface now. Actually, I want to maybe move it slightly this way, just so the opening is centered around a corner. Very nice. I can now turn off my reference line. This void is still there and visible, But don't worry, it won't show up in your project once you have this loaded in. Next step now is to select the surface. You may have to press tab a few times. The trick here is you need to select the surface that has been cut. For example, if I try and get the wrong one, as you can see, I can get this surface, but as you can see there, when I try to highlight these edges, there's no edges highlighted there. That means if I use this surface, my panels will go across this opening, and that's wrong. I need to press tab now until I can see the boundaries of that opening cut highlighted as well. Like right now, that's when I can click to select. The second thing is to make sure you select the surface and not the form. As you can see now, the surface seems to be correct, but I have no divide surface button on the ribbon. That's because I have selected a form, not a surface. We need to now press tab a few more times until you see the correct boundaries highlighted up, and also on the tooltip, it should say face at the end. Now when I can select it, I also have the divide surface button available. Once that's divided, we can change the pattern to be hexagon. And then just start changing those numbers to kind of the same dimensions we have in the panel family. Okay, so that gives an error. When you see this error, that means that the number of panels or grid lines on the surface is more than the limit that Revit has per surface. That limit is 199 grid lines in any direction. If I now cancel this, let's change this to fixed number. Let's change this to 199, and this one may be 50. So you can see that generated properly. But as soon as I take this number to 200, see what happens. We get the same error. It's just a limitation of Revit. Somehow it doesn't want you to create geometry that is too complex. If that happens and you really want to take this number over 199, consider dividing the surface to smaller ones, just so that each one doesn't have more than the number of grid lines that Revit allows. For today, I won't try to divide the surface, but once you have done that, the next steps will be the same. So divide your surface, and then you can load this panel family back into that massing family, family 2. Next step, we can now select the divided surface and change the hexagon pattern into using this button panel family. Alright, that's done generating. Now maybe our panel is a bit too close to one another. I would prefer to have a bigger gap there. But all you have to do is this. Go back to the panel family, go to the parameter list, and instead of dividing this by 2.5, maybe we can try 3. And that way our panels will be a bit smaller, and they will have bigger gaps between them. Once you've changed this value, just load it back into the massing family to have your panels updated. I won't do it now because that will take some more time to regenerate, but you get the idea. Next step is to load this mass into your project. Let's do new project. And here you can go and select the mass family again. Then try to load this into project number 2, the one we just created. Let's do that now. When you see this, that's just Revit trying to turn on the mass category. You can close it. Now it can be hard to maneuver this because the mass is too heavy. So what I usually do is I just click here once to place the mass immediately, and then later on move it if I need to. Okay, it's placed now. Let's go to 3D and check it out. Very nice indeed. The next step is just to create the underlying surface of the system. If you look into this image, that's a blue surface there, which is a wall, but because it's a free-form element, we need to make this wall using another method. Let's go to wall by face, and then select a base wall type to develop from. Maybe this one there. I can now call the new type mass wall. Under structure, I don't need many layers here, so just delete everything except from one structural layer. 70 mil is fine. For the material, I want to make something as blue as this, so let's duplicate this one there. You can call it as you like. For now, let's do blue wall and change this color now to blue. Okay now. And with the wall type new and ready, we can do wall by face again. Make sure mask wall is selected. And then you can pick the underlying surface of this mask. As soon as you can get it highlighted, select it by clicking. Let's try that now. And you can see the wall seems to be clashing a lot with our panels. Let's undo this. The reason was that the face we used to generate the wall was its exterior face. This is a bit fuzzy of a concept because sometimes if you want the wall to look right when you create it by mask face, you need to change this to something else. So instead of exterior, I will need to do the opposite, and that's interior. Let's pick the same face again. And this time it's correct. As you can see here, some panels are still clashing with the wall itself, so that means we need to now select the panel in the system. Any one of them will do. We go to edit type now, and increase the base offset value. Let's do maybe 100, and press OK. Here we go. Now the panel looks much better. Some of them are still very close to one another, like you see there. But as I mentioned before, you can easily fix that in the panel family. And then reload this into the mask family, and then reload the mask family into the project. Eventually, you will get something as close to this as possible. And that, to me, is close enough to our reference project. Alright, if you like tutorials like this coming to you every single day, make sure to subscribe to this channel. For now, have a practice with this, and I'll see you in the next lesson.